All right, let's dive right in. We're going to talk about something called atmospheric pollution. Now, I want you to think of our planet's atmosphere like a giant invisible blanket. It's perfect, right? It keeps us all warm and cozy. But what happens if that blanket starts getting a little too thick?
Yeah, that's the big question we're tackling today. Is our planet's blanket getting too thick? And this isn't just about things getting a bit warmer. It's about a huge shift in the very system that makes our planet livable. So to really get what's going wrong, we've got to first understand how it's all supposed to work in the first place.
So let's talk about this protective blanket. How does it actually do its job? Well, in its natural state, Earth's atmosphere is an incredible life support system. It's designed to trap just the right amount of heat to keep everything in balance.
And this natural process, it has a name, the greenhouse effect. And I gotta stress this, it's not a bad thing. In fact, it's absolutely essential. Without the greenhouse effect, Earth would be a frozen wasteland, way, way too cold for life as we know it. It's this beautiful, natural balancing act.
The gases that do all this heavy lifting are called, you guessed it, greenhouse gases. The main players you'll hear about are carbon dioxide, methane, and even simple water vapor. See, they're really good at letting sunlight pass through them, but they're great at absorbing the heat that bounces back from the Earth's surface. Kind of like the glass in a greenhouse, right? It lets the light in, but keeps the warmth from getting out.
So here's the twist. The gases themselves aren't the villains here. The real problem is that we're dealing with too much of a good thing. Human activities are pumping massive, extra amounts of these gases into the air, essentially making our perfect blanket way too thick and way too good at trapping heat.
You can actually see this happen with a super simple experiment. Picture this. You take two identical bottles with thermometers inside. In one of them, you pop an effervescent tablet to add a bunch of extra CO2. Then you stick a lamp, our very own mini sun, over both and just watch the thermometers. Any guesses what happens?
Well, the result is, it's crystal clear. The temperature inside the bottle with the extra carbon dioxide shoots up faster and stays higher. That CO2 is literally trapping more heat. It's the perfect little demonstration of what's happening to our entire atmosphere on a massive scale. Okay, so if we're the ones adding all these extra gases, where exactly is all this stuff coming from? Turns out, the sources are tied into almost every part of our modern lives.
Let's break it down. The big one is burning fossil fuels. The coal, oil, and gas that power our homes, our factories, and our cars. Then you've got farming. Livestock, especially cows, produce a powerful greenhouse gas called methane. And finally, there's deforestation. When we chop down forests, we're not just getting rid of trees that absorb CO2, we're also often releasing all the carbon that was stored in them for centuries right back into the atmosphere.
So, with all these extra gases making the blanket thicker and thicker, the whole planet starts to heat up. We call this global warming. But that warming leads to much bigger, more complicated ripple effects all across the globe. And that's what scientists call climate change. And the impacts, well, they create a pretty scary domino effect. A warmer planet means more extreme weather, intense heat waves, bigger storms, worse floods. All that heat melts polar ice, which makes sea levels rise. Vital habitats like our beautiful coral reefs can't survive in warmer oceans. And all of this, of course, puts so many plants and animals at risk of disappearing forever.
Okay, I know. That's a lot, and it can feel pretty heavy. But here's the thing. The story doesn't end there. Understanding the problem is the absolute first step toward being part of the solution. And, as we're about to see, change can start with some pretty small, everyday stuff.
This is where you and I come in. Simple choices really do add up. Deciding to walk or take a bike instead of driving, that cuts down on transport emissions. Just buying less stuff in general means less energy is needed for manufacturing and shipping. And even shifting your diet to include more plant-based foods can reduce the demand for all that methane-producing livestock.
And speaking of farming, you gotta hear this. This is so cool. Scientists found a special breed of sheep in Scotland. And get this, when they eat seaweed, they produce way less methane. It's just a fantastic example of how people are finding really clever and sometimes totally unexpected solutions to these huge problems.
All right, now for what might be the most important skill we talk about today. When a topic is this big, you're going to hear a lot of different voices with a lot of different opinions. Being able to tell the difference between a solid fact and a biased opinion is like a superpower. So what is scientific bias? It's basically when someone's personal agenda, their job, their beliefs, their company's bottom line, colors how they interpret and present scientific facts. They might only show you the data that helps their case.
So let's put our new superpower to the test.
First up, we have a quote from Mrs. M. She's a publicity manager for a large petrol company, and she says, "The evidence that humans are causing this global warming is not certain."
So, what do we think? Is this likely biased? Oh, for sure. Her entire job is to protect her company's image, and that company sells the very fossil fuels we've been talking about. She has a huge financial incentive to create doubt about any science that might make her industry look bad. Okay, next up is Professor A. She's a climate scientist at the University of Cairo, and she says, "I am in no doubt that humans are causing climate change."
And what about this statement? Is it biased? It's very unlikely. See, as a scientist, her conclusions aren't just personal opinions. They're based on years of research and data that have been reviewed and checked by other experts in her field. Her professional reputation depends on being accurate and evidence-based.
Last one. Here's Mr. D, who's the director of science at a big flour company. He says that since rice farming creates methane, everyone who eats rice should just switch to eating bread. This one is a textbook example of bias. First off, there's a glaring financial motive, right? His company would make a fortune if everyone bought more bread. But there's a second problem. His reasoning is totally flawed. He's completely ignoring the fact that billions of people depend on rice, and that it grows in places where we could never survive. It's not just biased, it's bad science.
So there you have it. We've talked about how our planet's blanket works, why it's getting too thick, and what that means for all of us. But more than that, now you have the tools to sort through the noise and find the facts. So that leaves just one question. Now that you have this skill, what are you curious to find out next? The journey is just beginning.